My dear students of 12th Science, welcome back to division physics classes. In my previous physics class, we discussed there about motional EMF. Today, we want to discuss about the method of generating the induced EMF. From the Faraday's experiment, we know that whenever in a circuit or coil, there will be some change of magnetic flux takes place in that coil or circuit, there will be some induced EMF is produced. In a coil or circuit, mathematically the magnetic flux linkage is given by phi equal VA cos theta. So if we can change the magnitude of this magnetic flux linking with a circuit, then in that circuit there will be some induced EMF. And there are three different methods by which we can change the magnetic flux linked with a circuit or coil. See, number one method, changing the magnetic field. From this expression we can say that if we can change the magnitude of the magnetic field, the magnetic flux linking with the coil is changes, means in that coil there will be some induced EMF. Number two method, changing the area of coil, means if we can change the area of a coil over the magnetic field, then the magnetic flux link with the coil is changes, means in that coil there will be some induced EMF. And number three method is changing the relative orientation of coil and the magnetic field, that is a value of theta actually. Now see the diagram very carefully. Here we consider a magnetic field B over which a coil is rotated with an angular velocity omega. Okay, and at any instant of time t, we consider the coil rotate through an angle theta. So therefore magnetic flux linked with the coil at that instant of time is given by phi equal VA cos theta. And for the angular motion we know theta equal omega t. So therefore phi equal BA cos omega t. Clear? Now as the coil is rotated over the magnetic field, the magnetic flux linked with the coil is also changes, means in that coil there will be some induced EMF. And from the Faraday's second law, the induced EMF is given by E equal minus d phi by dt is equal minus ddt of phi means BA cos omega t. Now this is the differentiation with respect to time, that's why here BA and omega are constant. Therefore E equal BA moves out of the differentiation ddt of cos omega t. And remember the differentiation of cos is minus sign, that's why minus minus plus BA, omega is constant, that's why omega sin omega t. So this is the expression for induced EMF whenever a coil is rotated with an angular velocity omega over the magnetic field B. Okay, now if the coil having n number of turns, then the induced EMF is given by NBA omega sin omega t. From this expression we can say the induced EMF becomes maximum whenever sin omega t is equal 1. So therefore E equal E naught equal NBA omega, which is the maximum value of induced EMF. So therefore in terms of E naught, this expression can be written as E equal E naught sin omega t, which is the expression for alternating EMF. So means by any one of these three methods we can produce the induced EMF across a coil or circuit. And student, remember the method 3, actually it is the theory of generator. Now we have to know our next topic, which is self-induction. This is very important for your exam purpose. To know about the phenomenon of self-induction, we have to analyze this circuit. See the circuit very carefully. This circuit consists of a coil, a battery and a tapping key which are connected in series. Whenever tapping key is just closed, the current through the coil increases. As the current through the coil increases, the magnetic field produced by the coil is also increases, means the magnetic flux linking with the coil is also increases, means there will be some induced current. And according to Lenz, the induced current across the coil produced in a direction such that it can oppose the battery current. Therefore, whenever the tapping key is closed, the induced current through the coil flow in a direction opposite to the direction of battery current. Opposite to the direction of battery current. Now, after reaching the maximum value of current through the coil, if the tapping key is released, then the current through the coil decreases, means the magnetic flux linking with the coil decreases, means in this situation the induced current across the coil produce such a direction such that it will oppose the decrease of battery current through the coil, means whenever the tapping key is released, then the induced current through the coil flow along the same directions of battery current. So now from these two different situations we can say that here we change the magnetic flux in a coil, and in that coil there will be some induced current. That's why this phenomenon is actually called self-induction. Self-induction. So what is the definition of self-induction? The phenomenon of production of induced EMF or current in a coil when a changing current pass through it. When a changing current pass through it. Now, student, from our discussion, at any instant of time, if I be the current pass through the coil, then we can say that the magnetic flux linking with the coil is proportional to the amount of current. So therefore, phi is proportional to I. If we omit this proportionality, there will be a constant which is given by capital L. So therefore, phi equal Li, where L is known as coefficient of self-induction or self-inductance. Okay, so now if this magnetic flux linking with the coil changes, then from Faraday's second law, the induced EMF across the coil is given by E equal minus d phi by dt, is equal minus ddt of phi is Li, L is constant, moves out of the differentiation, that's why minus L di by dt. So this is the expression for induced EMF across this coil. Now student, from these two equations 1 and 2, we can define the self-inductance. From here, if I equal 1, then phi equal L. So means what is the definition? The self-inductance of a coil is numerically equal to the magnetic flux linking with that coil whenever unit current pass through it. Whenever unit current pass through it. Now, from the second equation, if di by dt equal 1, then E equal L, neglecting the minus sign. From here, how can you define L? The self-inductance of a coil is numerically equal to the induced EMF in that coil whenever the rate of change of current through that coil is unit. Whenever rate of change of current through this coil is unit. Okay, now student, the SI unit of this self-inductance is Henry and the dimensional formula is ml square t to the power minus 2 a to the power minus 2. This is the dimensional formula. Remember it. This is important for your MCQ questions. Now student, we have to derive an expression for self-inductance of a long air core solenoid. That is self-inductance of a long solenoid. Now, we consider a solenoid of length small l, area of cross section capital A, and the number of turns per unit length is small n. If I be the current passed through the solenoid, then the magnetic field inside the solenoid is given by B equal mu naught Ni. Okay, so as there will be some magnetic field inside the solenoid, then magnetic flux linked with each turn is equal BA, because this is the definition of magnetic flux. BA. Now putting the value of B from here, the expression becomes mu naught NIA. Total magnetic flux linked with the solenoid. Phi equal BAN. What is N? The total number of turns of the solenoid. So therefore BAN is the total magnetic flux linked with the solenoid, which is equal, BA is mu naught NIA from here multiplied with N. Okay, so this is an expression for total magnetic flux linking with the solenoid. And from the definition of flux, phi equal Li. Okay, so this is our equation number 2. Now see, equation number 1 and 2, their left hand sides are equal, therefore their right hand sides are also equal. So therefore from 1 and 2 we get Li equal mu naught NIAN. From both sides I cancelled, so therefore L equal mu naught. In place of small n, we can write total number of turns by length of the solenoid, that is capital N by L, A into N. So therefore L equal mu naught N into N, N square A by L. So therefore this is the expression for self-inductance of a long air-cooled solenoid. Now student, why we take a long solenoid? Because in case of long solenoid only, the magnetic field inside the solenoid is uniform. That's why whenever we want to determine the self-inductance of a solenoid, you have to consider a long solenoid. Now student, read all this portion very carefully. Thank you.